The internet has given the human race a great many things. Massive diffusion and consumption of information, connection to people all around the world, and lots of cats. Anyone who surfs the web regularly has at one time or another found themselves in a web of cat memes and videos. The internet has a seemingly endless obsession with them. But let's pretend for a second that we were an AI looking at a computer screen. How could we see cats at all? The current best-in-class solution for teaching an AI to see is based on something called a convolutional neural network. We've talked about neural networks in a previous video. You can go watch that if you wish to jog your memory. For now, we can imagine a neural network is a black box that says yes or no when it's given a cat. The only problem is the black box is finicky and won't accept an image in the same way people do. We can't just provide a JPEG or a PNG or a PDF. We have to do more to allow our AI to see. Here's where the convolutional part comes in. We want to turn the image of a cat, which people can see, into something that our neural network can actually make sense of. If you remember from our neural network video, the language of neural networks is numbers. And fortunately, an image is just numbers too. Typically, we describe color images using the RGB format, a specific mixture of red, green, and blue. For the sake of simplicity, we can assume that 1 means all of that color, and 0 means none of that color, so that 1, 0, 0 is all red, no blue or green. And 1, 0.5, 0.5 means all of red, half of blue, and half of green mixed together. Okay, so how does this help us? All we have are a bunch of numbers, and we can just pass it through a neural network, right? Well, maybe. Let's say we're trying to build a neural network that says, yes, there is a cat in this image, or no, there isn't a cat in this image. And let's say we have a bunch of cat images like this, where the cat is in the bottom right portion of the photo. Assume we train a standard neural network, and it learns to identify cat images like this. Then, we present it with a new image, with the same exact cat, except now, the cat is in the bottom left corner. The neural network says, no, there isn't a cat in this image. That's a problem, and a major hint for how we can improve our solution. When we're trying to identify something in an image, where exactly it is in the image can't be relied on. We need to achieve location invariance. What's more, it's obvious that the pixels closest to each other have more of a relationship to each other than the pixels that are far away. That is, there is spatial correlation between the pixels in our images. So how can we account for these two aspects of image data? The solution used in convolutional neural networks is what's known as a sliding window. Basically, we pass a little window over our image, combining the pixel values and projecting them down into a smaller number. We may add, subtract, or multiply the pixel values to combine them into a single value. We may even do this a few times, learning different things at each layer, like fur patterns or cat-specific features like tails or ears. After we've done this, we connect that output to a standard neural network. The important thing is that we're now no longer relying on exactly where in the image something is. The sliding window, which applies the same transformation everywhere in the image, lets us capture the notion that a cat in the top left corner is the same as a cat in the bottom right corner. What's more, the sliding window acknowledges that pixels that are close by have a much stronger relationship to each other. The final outcome of this technique is that we can now use neural networks to identify cats in pictures. In all seriousness, the positive applications here are enormous. Helping blind people see, making our living and working spaces smarter, and realizing criminal activity in real time. The negative consequences are just as scary as the positive ones are inspiring. We can identify you if you're jaywalking, find your face anywhere on the internet, and make snap judgments about your health just based on appearance. But in a world rife with inequality and deeply entrenched societal problems, there's nothing like a fun widget for pointing out cats.